Section 7.2 is about solving trigonometric equations. So in 7.1 we were verifying identities, and an identity is an expression in which the left side of the equation equals the right side for any and all values of the variable. In other words, there's an infinite number of solutions for the equation. And so that's why when we were solving an identity, we were just trying to transform one of the sides so it actually looked exactly like the other side. If a trigonometric equation is not an identity, then we need to find solutions using algebraic techniques. So just like we did in algebra when we were finding solutions, we were finding the values of x that would make the equation true. And sometimes there's more than one, and in trigonometric equations there is more often going to be more than one. So this may involve factoring or substitution, and in this case a lot of times when we're using substitution we're going to be using the identities that we've already been exposed to, and also we're going to be learning some new identities to rewrite parts of the expression. Finally, if degree measure is not specified, then all solutions of a trigonometric equation should be expressed in exact radian measure. So in other words, your answers are generally going to be in terms of pi rather than degree measures. If it asks for degrees, obviously you're going to be giving degrees. Really the only way to solve these, or to figure out how to solve these, is to jump right in and solve a trigonometric equation. So the first one, find the solutions of the equation, first of all a that is in the interval 0 to 2 pi, and b if we were going to extend that to using any real number. So we're going to start off with one that's fairly simple, fairly straightforward. We want to know when is the sine of theta equal to 1/2. And so this is when we can come back to either the unit circle, or you can also think of that sine wave. So we're going to look at this problem both ways. If we think about the unit circle, remember the sine of theta is the y-coordinate. So we want to know where on the unit circle the y-coordinate is equal to a positive 1/2. So we see right here, so theta equals pi over 6. But remember, it repeats, so there's going to be more than one place. So we're going to continue looking at the y-coordinates. Here's another one, 5 pi over 6. So theta equals 5 pi over 6. And we're going to continue on, and then if you think about it, down here, my y-coordinates are all negative because they're underneath the x-axis. Looking at the graph, I have the sine wave graphed, and then right here is the line y equals 1/2. So where do those two intersect? Well, we have here pi over 6, and we have here again 5 pi over 6. But if you notice, it happens all the time, right? Because the sine wave just continues up and down. You could also think about that as going around and around the circle. So these would be the solutions to answer part A, the solutions between 0 and 2 pi. But if we wanted to know any place, well, if we have pi over 6, how long until it comes back around to pi over 6? Well, we're going to add every 2 pi, right? We can just add 2 pi to that. Well, we could add 2 pi again. The way we signify that in trig is we just say 2 pi n. And in trig we understand that that n has to be a whole number. So we can plug any whole number in for that n, and we simplify that, we're going to get another place that the sine is 1/2. Similarly, we can say 5 pi over 6, because 5 pi over 6 is here, we still have to go around 2 pi to get there again. So this is going to answer part B. This is when theta can be any real number. All right, number 2. Number 2, again, we're just going to kind of get used to using the whole unit circle to answer these questions. So we need to know when the tangent of u is equal to -1. Well, remember the tangent is the sine over the cosine. So we need to know when the sine over cosine is equal to -1. Well, in order to get a fraction equal to -1, doesn't the numerator and denominator have to be the exact same thing? Well, they have to be the opposite, right? One is going to be positive and one is going to be negative. So we need to know when is the sine of u equal to the same thing as the cosine of u, but opposite. So again, let's take a look at the unit circle. When do my x and y coordinates have the exact same measurement, or the exact same fraction, but opposite? Well, here's square root of 2 over 2 and square root of 2 over 2, but those are the same sign. We're going to keep going around. Here's Here they're the same thing but opposite. So u is going to be 3 pi over 4. And let's keep going around. Here they have the same thing but they're both negative. So if we keep going right here at 7 pi over 4. So those would be the two specific solutions between 0 and 2 pi. But what if we wanted to write that in terms of just one general solution? Well, 3 pi over 4. 3 pi over 4 is here, but if we notice, 7 pi over 4 is directly across from it. And how far is it if something is directly across from another one? It's just pi. So rather than writing this as 3 pi over 4 plus 2 pi n, and 7 pi over 4 plus 2 pi n, I can catch them all by just writing 3 pi over 4 plus a 1 pi n. 3 pi over 4 plus pi is going to get me to the 7 pi. Another pi is going to get me there. Another pi. So this is going to be the general solution. Number 3, we're going to solve this and express the solution in both degrees and radians and degrees. Cosine of 2x equals 0. Don't let that 2x fool you. Let's just change this for a second. Let's let 2x equal theta. So now we're really only solving when is the cosine of theta equal 0. Well, again, using the unit circle, let's do the radians first. Theta, when is cosine is x, so when is my x coordinate 0? Oh, here is it pi over 2. And where else is my x going to be 0? Here at 3 pi over 2. So those would be the two solutions between 0 and pi. 2 pi, sorry. Let's go around and do the same thing in degrees. Well, it's still up here. Straight up, my theta is going to be 90 degrees. And there's 180, so another 90 is going to be 270 degrees. So that's the two specific solutions between 0 and 2 pi, or between 0 and 360. But remember, my theta isn't actually a theta, it's actually 2x. So 2x plus equals pi over 2. Keep in mind that was plus pi n, because pi over 2 plus pi gets me down to that 3 pi. So to get my general solution, divide both sides by 2. I get pi over 4 plus pi over 2n is going to be my general solution. Make sure when you're doing your general solution, if you have something that you're doing a substitution like that, you write your general solution so that when you're dividing both of those terms. That's going to be my general solution. Over here, this is going to be 90 degrees plus 180 degrees, right, to get down to the bottom. But again, it's not theta, it's actually 2x. So my general solution in degrees, dividing both sides by 2, is every 45 degrees plus 90 degrees. Oops, I forgot my n. N. And this is my general solution. The next problem, again, we're solving this. This is not a verifying identity. So the first thing we need to do is bring the sign over to the other side. This is where our algebraic techniques come in. So far, these problems we've done haven't really involved any algebraic techniques, just involved using and learning and reading the unit circle. So now what can you do to this? Both of these terms have a sign, so go ahead and factor the sign out. Then after we factor the sign out, we're going to apply that zero product property, which means we can set both of those factors equal to 0. So now we need to know when is the sine of theta equal to 0, and when is the tangent of theta equal to a positive 1. So go ahead and use your unit circle, pause the video, and write down your solutions in radians. So to begin with, remember that the sine of theta equals 0 at 0 and pi and 2 pi, which those are all an even pi away from each other, so we could just simplify that for our general answer as 0 plus pi n, but 0 plus pi n is just pi n. Then the second one we have to look at our unit circle for is when is the tangent of theta equal 1? Remember the tangent is sine over cosine. When is a fraction equal to 1? When the numerator and denominator are equal to each other. So when on the unit circle is the sine and cosine exactly the same as each other. Those occur in the first and third quadrant, which we can then write our general solution. They are a whole pi away from each other. Whoops. So this is pi over 4 plus pi n. Problem number 5. Trying to factor this problem would be trying to factor something with a y squared and an x. We can't really do that. So what trig identity can we use to get rid of that sine squared? We can replace sine squared with Pythagorean identity, which is 1 minus the cosine squared. And then we're going to distribute and combine our like terms. First distributing, and then combining my like terms. And then, out of a personal preference, I'm going to multiply both sides of the equation, or divide both sides of the equation by a -1, so I have a leading positive squared term. Then hopefully you see an algebraic structure, that this is like 2x squared plus x minus 1. And if you can factor 2x squared plus x minus 1, then you can factor this. So go ahead and pause the video and do that, please. And from here on out, it's using the zero product property, setting both of those factors equal to 0, solving them and looking at the unit circle to find where t will be. Solving for the cosine of t, we get these. And here you have both the specific between 0 and 2 pi solutions and the general solutions. Problem number 6. You might be tempted to change the sine squared into something, but again, if you look at the algebraic structure of this, I have two terms, and they both have a tangent, so I'm going to start off by factoring a tangent out of both of them. Now I've got two terms being multiplied together, each with their own trig function, so I could just use the zero product property, set both of them equal to 0, and use my unit circle. So I have that the tangent of x equals 0, and the sine of x equals plus or minus 1/2 when you take the square root. So where on the unit circle does the tangent equal 0? And where does the sine equal plus or minus 1/2? Those will be your solutions between 0 and 2 pi. And these would be my 6 solutions. Now I'd like to have you pause and try to do number 7 on your own. Now I could get rid of the fourth root by taking a square root. So the square root of cosecant to the fourth is cosecant squared, and then I could take the square root again. Now the only reason I did not write the plus or minus in this step when I took the fourth root was because I could see that I was going to have to take the square root again, and I couldn't take the square root of a negative number. So those solutions are imaginary solutions which we are not going to deal with. Now I have the cosecant equals 2u. Now let's change the cosecant into its sine counterpart. Cosecant is 1 over the sine. Now if I were to multiply both sides by the sine of 2u and then divide by the square root, I would end up with, I got rid of that 2 that u that I actually accidentally wrote there. So now when I rationalize the denominator, I'm going to end up with plus or minus the square root of 2 over 2. So now we're going to look at where is the sine equal to plus or minus the square root of 2 over 2. So that's what the 2u equals, and now we have to find what u equals. So we're going to divide by 2, or it would be easier to multiply by 1/2. And there are my solutions. Now the next problem I would challenge you to factor by grouping. There are 4 terms in it, so try to pause and factor this and solve this one on your own. I get that the sine of theta is equal to 2, but remember that the sine of theta has a range of -1 to 1, so that does not going to give us an answer. And here I get that the tangent of theta equals -3/5. Since that is not one of our special angles, we would have to use our calculator. I did these a little bit in the last chapter, and when I do that, I'm going to get that the tangent, or that theta equals -31 degrees. Also remember that that's going to give us our reference angle. Tangent is negative in the second and fourth quadrants. So to find the actual angle, we're going to take 180 minus the 31 and 360 minus the 31. And there will be one more very short video posted for the last problem. on this note packet. See you in class.